Okay, we need to talk about enthalpy. So enthalpy is a combination of, it kind of represents the energy and the work of a system. So the symbol is H, and it's equal to the internal energy of the system plus the work that it's been doing. So U is the internal energy of the system. You might also see E. And PV represents the work that's being done by the system. That can be positive or negative. And if you look at delta H, then that's going to be equal to delta U plus P delta V, right? Assuming constant pressure. So the change in enthalpy is going to be equal to the change in the energy plus the change in the work, right? Makes sense. If we are in a constant volume system, so we're not doing any work, so no delta V is 0, so there's no work done, then delta H is just equal to delta U, and delta U is equal to Q, so delta H is equal to Q. So when we're talking about enthalpy in chemistry terms, we are simply talking about the heat. And what makes it different from Q is like the heat content of an individual instance. Whereas enthalpy, generally speaking, we're looking at a reaction. We're looking at it's always this. Like the enthalpy of a certain reaction won't change. So heat content Q is extensive, but enthalpy is intensive. So enthalpy doesn't change. Q does, because, if you have more stuff, then Q is going to be bigger. But for enthalpy is done in terms of moles, so that's always going to be the same. So, enthalpy is what is called a state function. Okay, so the only thing that matters are the initial and final states, and it's what we would call path independent. So, to give you an idea of what that means, I live in Charlotte. I want to drive to Atlanta. So to drive from Charlotte to Atlanta, it's straight down 85 south. It really is a straight shot. Now, you'll notice something that's always bothered me is that it is more east-west than north-south. So who decided that was 85 north? But whatever. It's about 250 miles. If I just drive straight there, it really is a very straight shot. So as the crow flies, 250 miles, that's about what it is, right? If I was an insane person, and or an incredibly wealthy person with a ton of money on my time, I could get in a hot air balloon, and I could go all the way around the world and wind up in Atlanta. And that's about a 24,000-mile trip, depending on where on the equator I'm traveling. So maybe a little less. So that would take significantly longer, 80 days, give or take, and be much more expensive. But my position that I started in Charlotte and then I ended in Atlanta would be the same. So my location is a state function. The travel path that I took didn't matter. So my location, my geographic location, is a state function. It is path independent. If I start in Charlotte and I end up in Atlanta, that's the only thing that matters. How I got there doesn't matter. So enthalpy is the same way. So generally speaking, we're using it to talk about heats of reactions in kilojoules per mole. So the neutralization of hydrochloric acid has a delta H of negative 57.9 kilojoules per mole. That means for every mole of sodium chloride, every mole of sodium chloride that's produced, it also produces 57.9 kilojoules of energy. And so positive delta H means that the reaction is endothermic. Negative delta H means it's exothermic. So this reaction would be exothermic. So heat can be treated as either a reactant or as a product. So in this case, we would put it on the product side because it's exothermic. If it was endothermic, we would put it on the reactant side. But that's what enthalpy is, and it ends up coming up a lot in chemistry.